Module 2, problem number 12. The shape of the distribution of the time required to get an oil change at a 10-minute oil change facility is unknown. However, records indicate that the mean time is 11.5 minutes and the standard deviation is 4.6 minutes. Complete parts A through C. To compute probabilities regarding the sample mean using the normal model, what size sample would be required? So one of the things that we read about in the lesson this week is that it needs to be at least 30 for the sample model. So that tells us that the answer is A. The sample size needs to be greater than or equal to 30. Nice work. Part B, what is the probability that a random sample of n equals 40 oil changes result in a sample mean time less than 10 minutes? So there's a couple ways to do this. You can do this manually using the lookup table, or you can use StatCrunch. I'm going to show you both ways. In both cases, the first thing you need to do now is find your new mean. That's mu x bar, the mean of x bar, the sample mean, and the new standard deviation, the standard deviation of x bar, sigma x bar. Remember, we're not just looking at any random person that comes in. We're looking at 40 of these oil changes, and we want to know the likelihood or the probability that those 40 oil changes mean is less than or equal to 10. That's different than just saying what's the probability that someone coming through the door is less than 10 minutes. So first we need to do, as we also learned from the lesson this week, we learned that mu x bar is equal to mu, or the mean of the population. So here we have 11.5. And then sigma x bar equals sigma over the square root of n. Well, we're given sigma just like we were given the mean. That's right here, 4.6, and we're given our n is equal to 40. So when we type that into the calculator, we get about 0.727324. Now, we can use just that information and go straight into StatCrunch and input that information. Really quick, I'm going to show you how to do it in the lookup table. So to do that, you need to convert your x, which is that 10 minutes, that's your x, to a z value. So remember again from the lesson, z equals x minus the mean. In this case, it's mu x bar over sigma x bar. So that's going to give us 10 minus 11.5 all over that sigma x bar, which equals about negative 2.06. Now, when we take that, we can go to the lookup table, which I've opened here. Remember, that's under Learning Modules, My Stat Lab, Tools for Success, Appendices, Appendix A, and scroll all the way down. Don't worry if you don't remember that path. It was in my announcements earlier this week. I highly recommend bookmarking it, though, just for ease of use. So our z value is negative 2.06. That means we come over here to negative 2, and then we go across to 0.6. This right here is the probability that that value is less than negative 2.06 on the standard normal distribution. But that's equivalent then to that less than or equal to 10 minutes because we converted it. So from there, we would know that our answer is 0.09197. The other way to do this in StatCrunch, which is easier and quicker and a little less error prone because you can make little mistakes. Let's go ahead and go to StatCrunch. I'm going to pop that window out just so we can shrink it down and look at both, look at them all together. So you're going to go to Stat, Calculators, and you're going to go down to Normal. Again, we're using this normal calculator. So we're going to use this along with that mean and that standard deviation that we just found. So here you notice when you open it up right away, it automatically assumes a standard normal distribution. That means that it assumes that your mean is 0 and your standard deviation is 1. However, we don't have that, so we can change that. It's 11.5, and this is 0.727324. Now remember, we're looking to see what's the probability that x is less than or equal to 10. So we're going to put in 10 here and click compute. And as you see here, we get 0.019, and when we round, that's 6. What we found on the table was, where do we go here? 2 was 0.0197. You see they're very close. Of course, you're going to deal with some rounding issues. So let's go ahead and put in the number we get from StatCrunch just to see. 1096. Oops, 96. Check answer. Nice work. And if you put in that 97 from the table, that would have worked as well. Part C, suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 48 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, there would be a 10% chance of the mean oil change. Would there be a 10% chance of the mean oil change time being at or below what value? I think there's a little typo in there. This will be the goal established by the manager. There is a 10% chance of being at or below a mean oil change time of blank minutes. So if you saw my either my announcements or my problem 9 solution earlier this week, I call this like a reverse lookup. The way you need to do this in the table is you need to go find that closest value to 10%. We all know that 10% is the same thing as 0.1. So you go search for the closest value to 0.1. I'm seeing 0.103, 0.102, 0.1033, and that's 0.0985. So this right here is the closest value. That means that corresponds to a z-value of negative 1.28. You see that? Negative 1.2 here and 8 here. So that means z would equal negative 1.28, would correspond to that 10% chance. Now, in order to solve this manually using that, you would have to then come down. Let's come down a little bit. You would then have to solve for x. So we know what the z value is. When we solve for x using a little algebra, we know that x equals z times sigma, all added to that mean. When we plug those numbers in, just like this, negative 1.28, that's that z value we just found in the table, and multiply it by sigma, and then add 11.5, you get 10.569. That would be your answer. There's also an easy way to do this in StatCrunch again. So let's go ahead and look at StatCrunch. We don't need to change our mean or our standard deviation. We do need to delete that value. And what we want to do is clear this out so that it's showing 10% or that 0.1. It's telling StatCrunch, I want to know what x value corresponds to that 10% or that 0.1. Click compute and look, it gives us a number, 10.567. Let's see how close that is to our number. Oops, scroll down a little. Oops, sorry about that. There we go. Let's bring that up so we can look. We got 10.569 and they got 10.568. Again, very, very close. So clearly there's some rounding, but they got us basically the same answer. So you can do it either way. Let's go ahead and plug in our answer and check it. It says to round to 1 decimal place. That would be 10.6. Yep, check answer. Well done. So again, this one you can solve either in StatCrunch, which I do recommend. Once you've done it a couple times and you're comfortable with how to use the table and you just understand what's going on, I do recommend using StatCrunch. It's going to save you a lot of time and it's going to help you avoid little rounding errors or little mistakes in your math or writing notation. So either way, but that's how you do it in both StatCrunch and by hand. If you have any questions, let me know.